right, if you remember last time, we learned covalent bonding, which was two non-metals. And that was that system that used the Greek prefixes, like an example, CO2 would be carbon dioxide, one carbon, two oxygen. We did a worksheet, practice a little bit. You all seem to be pretty good at it. But here, let's try a little again. Carbon monoxide means, okay, one carbon, one oxygen. Carbon dioxide means one carbon, two oxygens. Hydrogen, that's one of our diatomics, so the formula is just H2. Dicarbon dioxide means two carbon, two oxygen. Pentanitrogen decahydride means 5 nitrogen, 10 hydrogen. So this is the covalent system is the pretty straightforward system. It tells you how many of each type you have. Okay, we got to remember those 7 diatomics. Hopefully you marked them on your periodic table. And if you see just the name just by itself, like chlorine down here, it means Cl2. If you see N2 somewhere just by itself, nothing else, it means the name is nitrogen. Okay, now we're going to talk about ionic bonding. And to do ionic bonding, it's a metal and a non-metal. Right? Covalent was 2 nonmetals. Ionic is a metal and a non-metal. Example would be sodium chloride. But when doing these, what you got to look for are charges. So on your periodic table, you need to mark up these charges on the top of your, across the top of your periodic table. But if you look, sodium right here, it's in the +1 group. Its charge is +1. Chloride, Cl, it's over here. Its group is in the -1. So sodiums are +1. Chlorines like to be -1. So it takes 1 sodium to balance 1 chloride. So for sodium chloride, the formula is NaCl, one of each. All right. Now for your periodic table, to make sure you write on your periodic table what these charges are. This first row over here, or first column, everything has 1 valence electron. It likes to have 8. The easiest path for it is to just lose 1 electron. So everything in this first group loses 1 electron, becomes a +1 charge. Everything in group 2 has 2 valence electrons, and it likes to lose those 2 to become a +2 charge atom. In group 3, we're talking just boron and aluminum here. They have 3 valence electrons, and in order to get to 8 valence electrons, it loses those outer 3. This fourth group here, the carbon group, has 4 valence electrons. Now, it's just as easy to lose or gain 4 electrons. So this group will either be plus or minus 4. Go to the nitrogen group. These ones have 5 valence electrons. This is the 5th tall group, and that means it has 5 valence electrons. In order to get to 8, it's easier to gain 3. So gaining 3 electrons gives it a -3 charge. The oxygen group, all the way down to the staircase, oxygen, sulfur, selenium, and tellurium, has 6 valence electrons. It wants to have 8. The easiest path is to gain 2. So these ones like to gain 2 electrons and form a -2 charge. The halogens here all have 7 valence electrons. To get to 8 that it wants, they all gain 1 valence. They all gain 1 electron to become -1 charged. The noble gases over here, they have 8. They don't like to do anything. They don't like to form a charge. So make sure your periodic table has those group charges, +1, +2, +3 for boron and aluminum, plus or -4 for carbon and silicon, and then all the way down to the staircase for -3, -2, and -1. Those charges are how you write the formulas for ionic compounds. Okay, let me just give you a little choice here. So we have a bunch of names here. Sodium chloride, potassium bromide, magnesium oxide, they are all a metal and a nonmetal. Okay, so the first one, sodium chloride, NaCl. The second one, KBr, magnesium oxide, MO, magnesium iodide, Mi, aluminum phosphide, AIP, ALP, calcium fluoride, CaF, LiS, and BeF. But that's not exactly how it works. You have to take the charges into account. You can't just put the name. And for these ionic compounds, we don't use those prefixes. Okay? To correct some of these, it's not one MgI, it's not one calcium, one fluoride, one lithium, one sulfur, one beryllium, one fluoride. When you use charges and you balance them out, and which I'll show you here in a minute, you don't use those prefixes. There's no prefixes here. We're going to look at the charges. And what we're going to do is called the crisscross method. So we're going to have an example. An example is calcium chloride. All right? And what we're going to do is we're going to start by writing the symbols, the metal one first. The symbol for calcium is Ca. And then you're going to write the nonmetal. The symbol for chloride is Cl. So step one is write the symbols. Step two is write their charges. And remember, you just put the charges above the groups on your periodic table. So for calcium, it's +2. For chloride, it's the -1 group. So the first step is to write the symbols. The second step is to write the charges. The third step is to cross those numbers down. So the calcium 2 becomes the subscript for chloride, and the 1 on chloride becomes the subscript for calcium. And then you reduce if you have to, and you don't write 1. So Ca1Cl2 becomes CaCl2. And if you think about it, hopefully this makes sense. If chloride is -1 and calcium is +2, it's going to take 2 -1 chlorides to balance that single +2 calcium. Calcium has 2 positives. You need 2 -1 chlorides to balance it, so CaCl2. So no prefixes here or anything. It's not calcium dichloride. It's just calcium chloride. But you use the charges to figure out what the formula is. Okay? Symbols, charges, cross them. Another example would be ammonium oxide. And first of all, we're going to get used to things called polyatomic ions. You're not going to find ammonium in the periodic table because it's not an atom. It's a polyatom ion. And you have a list of common ones on the bottom of your periodic table. You just got to start to get used to them. Okay? But what we do to this is the same thing. We're going to do that crisscross method. We have a positive polyatomic ion here and a negative nonmetal. So we're going to start with the symbols. And the symbol for ammonium is NH4. For oxygen, it's O. Symbols, charges, NH4 is +1, oxygen is -2. We're going to cross those numbers down, so the 1 from ammonium becomes the subscript for oxygen, the 2 from oxygen becomes the subscript for ammonium, and we're going to reduce, but you can't reduce 2 and 1, they are already reduced. But what we're going to do here is make sure that we put parentheses. This is very mathematical. This 2 right here applies to the entire ammonium, so you have to put parentheses around the ammonium, so it becomes NH4 2O. Okay? Naming ionic compounds. So we have NaCl, it's sodium chloride. Pretty clear. FeO, iron oxide. Okay? Fe2O3, iron oxide. FeO2, iron oxide. Hopefully you notice there's a problem that you can't call all of these, this FeO, Fe2O3, and FeO2, iron oxide. They're different atoms, so you've got to use a different system. Here, remember we talked about this. Group 1 is +1, group 2 is +2, and then these are +3, plus or minus 4, minus 3, minus 2, and minus 1. But everything in the middle here, they like to form different charges. So iron isn't just plus 1 or plus 2, it's also plus 3 or plus 4. Vanadium can be plus 2, plus 3, plus 5, plus 7. They have various charges they can form. So for these transition metals in the middle of the periodic table, everything in blue here, you've got to also tell me the charge. So sodium chloride, well, that's a group 1, plus 1, and minus 1 chloride. So that's just sodium chloride. But if you look at iron oxide, FeO, you have to use a charge also. You have to tell me what the charge is. Here, and you can figure that out because you know that oxygen is minus 2. But it only takes one iron to balance it out, so I know iron must be plus 2. So this is iron 2 oxide. You have to tell me that charge on the iron. I know what oxygen's charge is. It's in group 6. It's always minus 2. But I've got to figure out what iron's charge is. For the next one, Fe2O3. All right. I know oxide is still minus 2. And there are a total of 3 of them. So that's minus 6 on the right-hand side of this formula. That means the iron part, the left-hand side, must be plus 6 to balance it out. There are 2 irons, so there must be 2 plus 3 irons to balance out those 3 negative 2 oxygens. FeO2. Oxygen is still 2 minus. There are 2 of them, so that's a total of 4 minus over here on the right-hand side. So the left-hand side must be plus 4. There's only 1 iron, so that's iron 4 oxide. All right? So this is a more difficult system than the covalence, and that's because there can be multiple charges on a lot of the atoms. Okay? And what you need to know is these Roman numerals. So for ionic compounds, if you have a transition metal, you've got to give the charge. And I don't know if you know all your Roman numerals, but they're written for you on the bottom of the periodic table. Just make sure you highlight it somewhere that it is indeed for ionic compounds. We have I, V, V, VI, VI. Right? You'll get used to them if you don't know them already. Okay. So it's a metal and a non-metal. An example, magnesium, this is MgBr2. Well, you write the names, magnesium bromide. You always end the second word in IDE, just like covalence. So this is, and you end it in IDE unless it's a polyatomic. So one of that lists on the bottom. So this becomes magnesium bromide. You write a charge if the metal is a transition metal. Magnesium's not, it's in group 2. So that's it. This is called magnesium bromide. Another example would be FeBr. All right? FeBr2 and FeBr3 and 4 and 7. So again, they can't all have the same name because they're different things. FeBr is 1 iron and 1 bromine. This is 1 iron and 2 bromines, 3 bromines, 4 bromines, 7 bromines. So they're completely different things, so they need different names. Bromide is always minus 1. So here, for the first one, you only need, iron must be plus 1 to balance it, so that's iron 1 bromide. For the second one, there's 2 negative 1 bromides, so iron must be plus 2, so that's iron 2 bromide. For the third one, there's 3 negative 1 bromides, so iron must be plus 3, iron 3 bromide. Just like this one, iron must be plus 4, and iron must be plus 7 to balance out those 7 negative 1 bromides, so iron 7 bromide. Okay, and remember, you use these charges only if it's a transition metal. So those D block metals and the ones under the staircase. All right, so what I want you to do is give this worksheet a try. It has a bunch of positives along the bottom, metals, and a bunch of non-metals across the top, or negative things in polyatomics. So you're just, in these boxes here, you're just going to do symbols charges across them. Like the first one, it's 1 sodium, 1 chloride. There's +1 and -1, so it's going to take 1 of each to balance it. If you go to the next one, it's +1 sodium plus -2 carbonate. Make sure to look at the polyatomic list at the bottom of your periodic table. So it's going to take 2 sodiums to balance out the carbonate. So it's going to be Na2CO3. Just give it a shot.